All right, we're on to the next session, Danny's security chat about CephX and brute force protections. You want to give us a little bit of a rundown and we'll take it away?
So we had the last few months a lot of discussion with Sage about security and Ceph, and one issue that came up was that currently there's not really a way to detect if somebody is trying to brute force CephX from within your system, and we thought about a solution, and the idea was, I don't know if it's really something we want, is to on one side to improve the logging for sure, to detect even cases that somebody is trying to authenticate on the system without the correct key. And the other one is to think about if we can implement in Ceph something to automatically blacklist somebody if it's, for example, let's say tried 10 times with the wrong key to authenticate on the system, and then block him. The question is here, what should we use to block him? Should we use the IP address, or is there anything else we can use to identify the attacker in this case? I mean, blocking an IP would also lead to potentially blocking a complete host and therefore blocking multiple other VMs or tenants or whatever, and that could be a problem maybe.
Yeah, so in general, when Ceph clients connect, they have specific nonce, and they try to get a globally unique ID assigned to them by the monitors. But I think that might be after they actually authenticate. So there might be, but we can certainly identify them not just by the IP, but also by the actual TCP connection they're using.
Okay.
Because they'll keep trying with the same like internal client nonce.
I
believe.
Yeah,
wait, I'm sorry, Josh. What did you mean by
that? When clients connect, they have their own unique identifier, right, that they generate based on how. I think it's mostly just based on their process ID and number.
But that's under the control of the client
to distinguish. Yes, that's true.
Not if they're trying to brute force someone's key. They can change it as much as they want.
Yeah, that doesn't have, yeah, that's a problem.
Yeah, I mean,
that's a good point.
I've used fail to ban a lot in the past, and that seems to be a pretty standard tool, at least on the Linux side. And I mean, it allows you to script whatever you want because it just scans log messages. So as long as you have a descripted enough log message saying this client by this IP address and authentication failed, then you can write fail to ban rules that say, well, when I see this from this IP address this many times and this often, initiate the following action, which it can run a new Ceph command of CephX, XYZ ban this host or whatever.
And Sage's specific concern is that might result in other VMs on the same host in the public cloud also getting kicked out.
Yeah, that's maybe an issue, but maybe in a usual cloud setup, the question is then you usually have no access to the Ceph network. So if somebody is brute forcing the Ceph on the direct network connection, and he already has broken out of the
sandbox.
Yeah, and besides, even with hosts, the hosts themselves would actually have their own IPs usually on the internal network.
Yeah. So
yes.
So it seems banning by IP is fine. Doesn't seem like a problem.
It makes sense because the host is compromised anyway. So
yeah.
Well, it could be an issue with things like the kernel client. Like a kernel client could be acting for many different actual tenants using the same mount or different mounts, but only shipped the same messenger implementation.
In that case, the client side, the trusted client portion needs to know enough to stop. So in other words, if it's possible to get the client to get the kernel client to constantly flood the monitors with incorrect authentication attempts, then the correct answer is still to block them. So the client would have to refuse to do that.
Yeah, that's what you're saying. It's certainly much simpler in the case where of VMs which don't have direct access to the network. So.
The other question is that somebody, where should we lock the attempts? Should that be something that even is after restarting a cluster available, or is it something we need to purge on a reboot, or is it something we should keep as information in the system permanently? I guess it would make sense, but it could grow a lot, and after some time you maybe want to clean it up.
If you're using Ceph's existing blacklist mechanism, that has an expiration time, which like defaults to 24 hours, for example. So we do something similar. Stored by the monitors for that amount of time. I'm not sure if that existing blacklist would work in this case. We might need to modify it a bit if we wanted to actually block this at the Ceph level instead of using like fail to ban to perhaps block at the network level.
It would be enough. It would be maybe enough to simply on the monitor side, if the authentication, if the caller is coming again, simply don't do anything and throw it away. So, or do we need more there? Yeah, I guess that's maybe it. If there are no questions, I have to take a look on that where to exactly implement it. I didn't take a deeper look so far.
So if it's in Ceph itself, it'll probably end up being in the monitor, which the part that handles the mon maps and authentication.
Yeah. So.
You suspect you've actually seen already, or is it just a theoretical concern at this point?
The problem is we have a security department and they have a lot of ideas how to penetrate the Ceph cluster in general, or a storage cluster in general, and that is one of the concerns. They want to be able at least to see it or to have some source for intrusion detection or penetration protection, and that is one requirement to get the cluster alive at the end. The problem is always how likely it is that the attacker gets there. I mean, in our case, we run virtualized network functions on this cloud, and first you need to break out that transport stream, and then you need to break out of the KVM instance, and it could be hard, but yeah, that is something that's maybe easy to implement and would help a lot. I'm sure also other people may have this problem.
I mean, if at the point where you're breaking out of the KVM instance, you already connected to the Ceph
cluster.
No.
Yeah, that's a problem. Yeah, I mean, you would also have this problem with if you use CephX in your if you use CephX in your cluster. If you mount it in the VM, then you have direct network access, and that would be another problem. So the client would maybe able always to access it. So, I mean, we don't use CephX for now, but that would be the problematic case, I guess. And there you need it at least because the client, the KVM instance guest has our full access rights in theory.
Yes, in that case, it does make perfect sense to just blacklist the whole IP.
Yeah.
Since it is the guest.
In this case, it makes perfect sense because yeah, the guest has an IP and they can block that. Yeah. And we discussed also in a lot of other stuff. One discussion we maybe could shortly discuss is to have a way to put the administration network or the network where the administrator connects to and send commands to the cluster to a different network than the public network. And the question is what if that makes sense for you or if it makes no sense, and how much effort that would be to have an additional network, separate network for only sending commands to monitors or OSGs. Yeah.
Yeah. It seems like it's a lot of work for not too much gain from a lot of perspectives, but if people are really interested in it, I mean, it's not that that's particularly difficult.
It only buys you something if other things on the public network can't be compromised to do damage, right? So what can the OSD do to other OSDs or to the monitor? And the answer is quite a lot. Once you control any OSD,
yeah, that's true.
Send spurious thing. Well, okay, so it would be pretty trivial to crash every OSD in the cluster. That wouldn't be hard. That would be really easy, in fact. Which is good, by the way, because if they didn't crash, they would do something really untoward, which would be bad. But yeah, if you sent them a spurious notify, they'd just crash, and so that's not good. You could mess with the monitor's PG temp mappings because OSDs are allowed to change the PG temp mappings of anything to whatever they want.
Yeah, the main.
Which wouldn't be good.
If I hear it would crash if you sent a strange command to it, that is very bad because that is the main.
To the other OSDs, and these aren't commands. These are OSD to OSD messages as part of the peering process. So these would be messages that algorithmically couldn't happen at that time. So something has gone very bad, right? But if you controlled the OSD and you were being malicious, then sure, why not? Oh yeah, you could send could send invalid OSD maps to anyone.
Yeah.
And I mean, or valid,
the idea is
not
to,
the same
to
as
simply,
everyone else's.
The idea was to simply take all the administrative commands out of it and put it on a control node and put the network only there and have no way from directly from any host guests to the Ceph cluster itself.
The purpose of doing that.
Send any commands.
Yeah, the virtue of doing that is in systems where the administrative commands are the destructive ones. But in our case, it's only some of the problematic ones. It may still be worth it. I don't know that it's that hard, but it wouldn't protect us from. There is a large set of things it wouldn't protect us from, I guess.
Yeah. Okay.
And the monitors could be signing OSD maps. We should probably be doing that. I mean, it checksums them, of course, so we can now, so we can tell if they got corrupted, but it doesn't sign them. That's something we can do.
Okay. Makes sense. Yeah. I guess that's it. So we had a lot of other topics, but that's not. Let's go over one by another. So that's the first one I would work on. The blacklisting for now.
That's it?
Yeah, from my side.
All of 13 minutes. All right. Oh.